Our first problem is the supply equation for a certain commodity is x equals 1000 times square root of 3p squared plus 20p, where x units are supplied per month and p dollars is the price per unit. Find the rate of change in the supply if the current price is $20 per unit and the price is increasing at the rate of $0.50 per month. So first we need to transform this x equals 10,000 times. We change this one as in this format. So then next we get derivatives. dx over dt equals this goes to here, so it turns 500 times and minus 1, so it's minus 1/2 times the one inside, it's 6p plus 20, and last the derivative of p. So here our p is $20 and the price increasing at the rate of 0.50. So we put it 500 times 3 times 20 squared plus 20 times 20 times 6 times 20 plus 20 and 0.50. So at last we get 0.25 times 140 times 0.50. So the final answer is 8,750 units. Thank you.
B. Spherical snowball is being made so that its volume is increasing at a rate of 8 cubic feet a minute. Find the rate of radius increase when the snowball is 4 feet in diameter. Okay, let's begin with the given. We have dV over dt, which is 8 cubic feet over a minute. Next, we have the radius, which we can get from the diameter, which will be 2 feet. And what we need to find is the rate of radius increase, which is d over dt. So we need to find that. So since it's a spherical snowball, we'll be using the formula of V equals 4/3 pi r cubed. Okay, so we just have to plug it in. So we have dV over dt equals 4/3 pi times 3 pi squared because we got the derivative times dy over dt. Okay, and we can cancel it out. So we have we put in the dv over dt, so we have 8 equals 4 pi squared times dy over dt. And to take this out, we divide both sides by 4. So, and then it becomes 2 equals pi 2 dy over dt. Next, we do the math, which is we make it 4 pi dy over dt 2. And next, we have to take this out, so divide both sides. So it's gonna, that's how we get the dy over dt. So we have dt, which will be 2 over 4 pi, which, if you do the math, will become 0.159 feet per minute.
So today we are given the question: a balloon leaves the ground at 500 feet away from an observer and rises vertically at a rate of 140 feet per minute. What is the rate? At what rate is the angle of inclination of the observer's line of sight increasing at the instant when the balloon is exactly 500 above the ground? So to show you a clearer picture, we will draw this question. So a person and a balloon, and the distance between them is 500 feet. And in the question it says, what is the angle of inclination at when the balloon is exactly 500 feet above the ground? So when the balloon is 500 feet above the ground, and as you can see, this forms a triangle. So we have the adjacent, which is 500 feet, and the opposite, which is also 500 feet. And here we have the hypotenuse. So back to the question, it is asking us what is the rate of change of the angle of inclination of the observer's line of sight. So to find that, we have to use theta equals opposite over adjacent. But this is to find the angle, but we have to find the rate of which the angle changes. So we have to look for the prime, or the rate of change. So it is secant adjacent times opposite prime plus opposite times adjacent prime over adjacent squared. So to find the secant, it is hypotenuse over adjacent. So here we have to find what is the hypotenuse And to find that, we have to go back. We have to go back to using the Pythagorean theorem. And the Pythagorean theorem is a squared plus b squared equals c squared. And just to label them, we can put a squared as adjacent. So it can be 500 squared plus, and b squared can be the opposite, which is 500 squared. And the c squared, which is the hypotenuse, is what we are trying to find. It's the c squared. So it is c equals square root of 500 plus 500, it's 500 squared plus 500 squared. So this is just 500 times the square root of 2. So going back to the secant, we can now input it. It is secant equals hypotenuse of this, which is 500 times square root of 2 over the adjacent, which is 500. So we can just cancel the 500 out, and it will become square root of 2. So moving on to this equation or formula, it is, or we can now input the values. So secant is square root of 2 squared theta equals adjacent, which is 500 times the change or the opposite prime. And to find that, it is just in the question. So it is 140 feet per minute plus opposite, which is 500 times the change of the adjacent, which is 0, because as we see in this drawing, the horizontal distance between the man and the balloon does not change. So it is still 0 over adjacent squared, which is just 500 squared. So here we can just cancel this out since it just becomes 0. So we are left with square root of theta equals 500 plus 140 squared. So this becomes so the answer of this is 0.14 radians per minute. So this is the change. So this is the change of the angle of inclination of the observer's line of sight. So to redraw this person, which is 500 feet above the ground. And the hypotenuse, which is 502. So as the balloon moves per minute, which is 140 feet, or the acceleration, it moves 140 feet per minute. So as 1 second passes, it's already in 640 feet above the ground. So this is the new line of sight of the observer, which changes by 0.114 radians.
Okay, so my question, I'll read it out. After blast off, a space shuttle climbs vertically and a radar tracking dish located 1,000 yards from the launch pad follows the shuttle. How fast is the radar dish revolving 10 seconds after the blast off? At that time, the velocity of the shuttle is 100 yards per second, and the shuttle is 500 yards above the ground. Okay, so to represent, this image will represent the space shuttle. Let's go on here. And according to what's given, there's a radar tracking dish 1,000 yards away. This image will represent the radar tracking dish. Now the radar tracking dish is following the shuttle. So it's following the shuttle. From this, so we can see that this image actually forms a triangle. This being the opposite, this being the adjacent, and this side being the hypotenuse. Okay, so it's given that the opposite, or the space shuttle, is 500 yards above the ground. Therefore, the opposite is 500 yards above the ground. It also says that the radar tracking dish is 1,000 yards away from the space shuttle. So the adjacent is 1,000 yards. Now it says that the space shuttle is rising horizontally at the rate of 1,000 yards per second. 100 yards per second. Okay, so for simplicity, we'll label the adjacent as A, which is 1,000 yards. The opposite as O, which is 500 yards. And the hypotenuse as H. We do not know the hypotenuse as of the moment. Okay, so the rate at which the adjacent changes is 0 yards per second. Why 0? Because hypothetically it says that the space shuttle is rising vertically, only vertically. Therefore, the distance of the rocket and the radar tracking dish in a horizontal sense does not change. So it does not matter how high the rocket rises, whether it's 1,000 yards, 2,000 yards. In a vertical sense, it will always be 1,000 yards away from the radar tracking dish. Therefore, the rate at which it changes is 0 yards per second. So 0 yards per second. The rate at which the opposite changes is 100 yards per second. So it rises 100 yards per second. The rate at which the hypotenuse changes, we do not know yet. Okay, so what we're looking is for how fast the radar tracking dish is revolving. So how fast is it moving up according to the space shuttle? So we're looking for the rate of which the angle changes, angle prime. We're looking for that, and we're given opposite and adjacent. So we're gonna use tangent tangent is equal to opposite over adjacent. Now we're actually looking for the prime of tangent, and the prime of tangent is secant squared angle, and the prime of this opposite and adjacent. So that will lead us to the quotient rule, and that will result to having adjacent times multiplied by the rate of which opposite changes added by opposite multiplied by the rate of which the adjacent changes, all over adjacent square. Okay, so now we have this. This is the main formula in which we'll find the angle. We're looking for the angle. But what is secant squared? Well, secant is equal to hypotenuse over adjacent. We do not have the hypotenuse yet, therefore we're gonna look for it. So using the Pythagorean theorem, which is a squared plus b squared equals c squared, a, let's say, being the adjacent, b being the opposite, and c being the hypotenuse, we have to look for c, which will result to a squared plus b squared square root. So the hypotenuse will be 1000 squared plus 500 squared square root. Using the answer is 1180.03 using a calculator. Okay, so the hypotenuse is 1180.03 yards. Okay, now that we have that, we can substitute it here. So going here, secant is equal to hypotenuse over adjacent. We're going to input the values. Therefore, it's going to end up 1118.03 over the adjacent, which is 1000 squared. They're both squared. Secant squared times theta equals adjacent 1000 times opposite, the rate of which opposite changes, which is 100, added by the opposite 500, multiplied by the rate of which adjacent changes, which is 0. That's cancelled out. All over adjacent square over adjacent, which is 1000 squared. Okay, so we're gonna have to look for the angle, therefore we have to isolate it. That will result in having 1000 multiplied by 100 times 1000 squared all over 1000 squared times 1180. Actually, it's added sometimes. Okay, so cancel this out. Will equal to 1000 times 100, or 100,000 divided by 118.03. The answer is 0.08 radians per second. Okay, so we know this is the rate at which the angle changes. Now I'll draw the updated image. Okay. So we have the rocket. We have the rocket, and it's 500 yards high, and it's rising at a rate of 100 yards per second. Now it's 1,000 yards away from a radar tracking dish. Which is following the rocket. That distance is 1,180.03 yards. The rate of which adjacent changes is 0 yards per second. Now the rate at which the angle changes is 0.08 radians, as we calculated, meaning that as the rocket rises, let's say after a second, 100 plus 5, the acceleration plus the distance will be 600 yards after a second. Therefore, the rocket, let's say, will be here. The angle will increase to remain following the shuttle. The radar dish has to revolve or increase its angle. There, it has to keep following the shuttle. This, or let's put it here, is the increase of angle, which is 0.08 radians per second. So again, to answer the question, how fast is the radar dish revolving 10 seconds after the blast off? The time the velocity of the shuttle is 100 yards per second and the shuttle is 500 yards above the ground. The answer is 0.08 radians per second. Thank you.
For our last question, we have here a funnel in the form of a cone is 10 inches across the top and 8 inches deep. Water is flowing into the funnel at the rate of 12 inches per second, 12 inches cubed per second, and out at the rate of 4 inches cubed per second. How fast is the surface of the water rising when it is 5 inches deep? So first, before we move on, let's illustrate that. So a funnel in the form of a cone. So we have that. It says here it's 10 inches across. So that's the diameter, 10 inches. And the height is 8 inches. Now, water is flowing into the funnel at the rate of 12 inches per second, cubed per second, and out at the rate of 4 inches cubed per second. Now, what we can do first is we can minus that. So 12 minus 4, simple subtraction, you get 8 inches cubed per second. Now, we're gonna get the relationship of the height to radius. So for that, if you divide this by 2 to get the radius, so height over radius is equal to 8 over 5. Cross multiply, we're trying to get now also, so first of all, that's a ratio. And here's our standard equation for the cone. Its volume is equal to 1/3 pi HR squared. Now, we'll use that. And what we have here, we don't have a radius, so we have to find it here. So we cross multiply, that's 5h is equal to 8r. So r is equal to 5h over 8. So we have here 5h over 8. And let's not forget the square. We have 1/3 pi times 5 over 8 squared h cubed. Now we get the derivative. So this value, 8 inches cubed per second, that is our volume prime. So v prime is equal to, we bring this down, chain rule, so we cancel out this, so it becomes pi times 5 over 8 squared times h squared times h prime. And then we substitute the values even further. That's 8 is equal to pi times 25 over 64 times, and our h here is one is 5 inches deep, so it's 5 squared times h prime. So h prime is equal to 8 times 64 divided by pi times 25 times another 25, and what we're ending up here is 0.26 inches per second. So you see, at the moment it is 5 inches deep. This is how fast the height changes. 0.26 inches per second. Okay, so thank you guys. I hope you learned a lot.